All right, key information that the name tells us the charge. So we said, for example, if it's copper 1 oxide, then when we crisscross it, we use the charge of +1 for copper, and we use the charge of -2 for oxygen, right? Here we used copper 2 oxide, so we have to use the charge of 2+ for copper, the charge of 2- for oxygen. Next week, when you get your assignment package, there's going to be some more practice with this stuff. I'll also, at the end of today's lesson, because today we're going to do a bit more about naming, I'm going to put just worksheets with just dozens and dozens of questions up, and you can just practice away. Does that make sense? It's the kind of thing, and I can't stress this enough, some people need to do 10 questions and then they get it. Some people need to do 50. Nothing wrong with you either way. You have to, part of being in a 3U course is you have to take a little bit of ownership of, hey, I need more practice, I better find some more. Or, yeah, I really get this, I'm comfortable, I'm bored of this, I don't need more practice. And you really have to decide that for yourself, because it is different for everyone. But I'll say, you don't really get it till the questions seem boring and easy. And then we talked about crisscrossing backwards, kind of, right? Or just eyeballing them to tell which charge we had if we have to go back and find the name. So we looked at the example of iron Fe2O3, and we said, is that iron 2 oxide or iron 3 oxide? Well, if we crisscross back to the charges, we see that that 3 ends up with the iron and the 2 with the oxygen, so it must have been iron 3 oxide. All right. I'm not going to spend too much time on that, because what I do want to look back is we talked about radicals. What's a radical?
Ions that are made up of more than one atom.
Yeah. Yeah. So here we have an example of one. What's this one called? Nitrate. And you can see it's got a nitrogen in the middle and it's surrounded by oxygens. Okay. And then we started looking at this chart, because there's not just nitrate, is there? If I put carbon in the middle, what would we call that? Carbonate. If I put chlorine in the middle, we would call it chlorate. If I put iodine in the middle, we would call it iodate. If I put phosphorus in the middle, we would call it phosphate. And if I put sulfur in the middle, we would call it good. You guys are so good. Okay, so we left off with the chart like this, and then we said the naming gets funky because there don't have to always be 3 oxygens, do there? We said that if there's 1 less oxygen, so let's look at chlorate, ClO3. If it was instead ClO2, still with a charge of -1, that's a real thing. What's that real thing called? Chlorite. Good. What if we had just ClO? What if it just had 1 oxygen? Still a -1 charge. We would call that hypochlorite. Good. What if instead of ClO3 it had 1 more oxygen? What would we call that then? Perchlorate. And what would its formula be again? ClO4, -1. Good. And what about iodine? Here we have iodate. It's IO3. If I add 1 more oxygen, what would it be called? Periodate. Good. So that prefix per tells us that it has to have 1 more oxygen, right? And so its formula would be what? IO4, -1. What if instead of adding an oxygen, what if we had an iodate, but it had 1 fewer? What would its formula be? IO2. What would its charge be? Yeah, the charge doesn't change, and it would be iodite. Good. And what if it had just 1 oxygen? What if it was IO -1? Hypoiodite. So 2 more examples. Phosphate. Now, if you look at phosphate, it normally has how many oxygens? Not 3, but 4. All right. And again, is there some way to magically figure these things out? No, you just need to memorize them. So all of the 8s, all of the standard ones, carbonate, nitrate, chlorate, iodate, phosphate, sulfate, you just have to know what they are. And the good news is this, we're going to use them so much, it won't feel like memorization. It'll just feel like how you know your cat's name, because you spend a lot of time with your cat. You can kind of think of phosphate as one of your cats. Do you? I don't like cats either. Your cat is trying to eat you. They're mean animals and they don't like people. Yes.
Mine does.
Okay. No, don't be fooled. When it
They
comes
only like you because they want something.
when it comes up and like nibbles your toes and you're like, oh, it's trying to eat you.
Yeah.
Just your cat is trying to consume you for food, and the only reason it doesn't eat you is its mouth isn't big enough. Anyway, that's true. Yeah, just hang on, because once we're done here, you'll print it and it'll have like all the information on it. So you might as well hang around while we talk about it. And then phosphate. So it's normally PO4. What would perphosphate be? What would its formula be?
PO5 -3.
Good.
Wait, I have a question.
Yeah.
Does it really matter where you put the negative sign?
No, and you'll see me do both.
Yeah.
It makes
so I was
no-
like, wait,
It makes no difference. Yeah, both are completely acceptable. What would PO3 -3 be called? Phosphite. Good. And what about PO2 -3? Yeah. This one doesn't actually happen in nature. It's rare. You can only create it in a lab, but still has a name.
Didn't you say that the hypo whatever is 2 fewer because all the other ones?
Yep. Yeah, but remember, phosphate's a weirdo because it starts with,
Take 1.
so phosphate has 4. 2. It just steps down. Does that make sense? Phosphate and sulfate are the weirdos. Right? They both have 4 in their standard form. And then so sulfate is SO4. What would persulfate be?
SO5
That's right. SO5 to negative. Good. And what would we call SO3 to negative? Sulfite. By the way, you'll see it sometimes with a pH. That's also right. And what would SO2 to negative be? Hyposulfite. Good. Okay, and that's the complete table there. Now, again, don't try to memorize the whole table. Unless, if you can memorize the whole table, go nuts. I certainly could not memorize that whole table. Memorize all of the 8s. Know carbonate, nitrate, chlorate, iodate, phosphate, and sulfate. Know that row, and then know how the rule works in terms of naming. Does that make sense? Okay, let's just do a few quick, simple examples. What is the formula of sodium, which doesn't start with an N, sodium phosphite? What's the formula of it? Yep. Oh, I did. Slow down. All right, smart stuff. Take a minute and do it. What rule do we use to figure out a formula? Crisscross rule. So everyone do that. Everyone crisscross this guy. Okay. Yeah, you can do it in your head. I'm going to always write it out because not everyone can do it in their head. Of course. By the way, guys, you don't have to ask me to go to the washroom. You're big kids. I trust you to manage your own
I can just
urinary
get up and
tracts.
leave when I have to go to the bathroom.
Yes. And if you're gone for 8 minutes, I'll mark you absent. You know what I mean? Like, you're big kids, and it's an elective course, and it's a senior U level. Like this.
Then one by
Beautiful. You can just stick it around the front desk. What was that?
So, what was I gonna ask you? The 1.8.
Yep.
Have they been marked? I can get that back to study.
They've not yet been marked, but I can give it back to you to study. Can you? Well, or if you want, if you catch me at the end of the day, I can give it back to you marked.
Okay,
Do you want to do that?
I'll come back to you.
Okay. Okay. All right. So how would we do this? Yep. Yes, you did. All right. So if we're going to crisscross this, what's the formula for sodium? Na. What charge does sodium take? Yeah, it always has a +1 because it's in the first group, right? It only has one electron to lose. What's the formula of phosphite? Yeah, if we look, phosphate is PO4. So ite always means one less oxygen than that. So it's going to be PO3. And phosphite, all of the phosphs have a charge of -3. All right, when we crisscross this, what do we get? Well, we get a 3 down here, and we get 1 down there, right? Do I need to write a 1? No. So I end up with 3 sodiums for every 1 phosphate ion. Does that make sense? Just the same crisscross rule we use for others. Yes, there's a lot of them there, but that's okay. Let's try one more example. Let's try magnesium chlorate. Magnesium chlorate.
How come like when you did the Na to the PO3,
Mhm.
how come when you actually wrote it down there to 3 instead of a 1?
So the 3 is part of the PO3.
Okay.
So this PO3 is its own thing. In fact, it actually looks like this. There's a phosphorus in the center, and there's 3 oxygens around it. And it bonds like that, which you don't need to worry about. You don't need to draw that. But PO3 is the ion. So when you crisscross, what this really is actually PO3, and we have 1 of them.
So you don't have to write the 1.
Yeah, we never write a 1.
Okay.
And so that's the only reason I didn't write it. But in this next example, we are going to have to write a number. And do you see how I just used brackets to say that the thing I had 1 of was that whole PO3? Whenever you have a polyatomic ion like this, we have to use brackets to say that it's not that I have 1 O, right? Without the brackets, it would look like I have 31 oxygens, which I don't, right?
Okay.
It's that this thing, this PO3, I have 1 of them. Good question, by the way. Very good question. Yeah. Well, I want you to walk me through it. What would I do? So Mg, okay, 2 plus?
Yeah.
Great.
And then the chlorate is ClO3.
ClO3,
It has a charge of
-1. By the way, if you look on the periodic table I gave you, it lists a few of the most common polyatomic ions. So you don't even have to necessarily remember chlorate, because that's probably in that list. Can you check? Is it?
Yeah.
Good. So there you go.
4-8, 4-8.
Perfect. So now, Paulquin, what do we do next in the crisscross rule?
I don't know. Right.
That's okay. I write them again, right?
Yeah. And which one, the 3 or the 1 to the Mg?
The 1. It's always the charge. Now, not the number. We don't take the negative sign with it, but the number from here goes down here. So what number does Mg get? Good. And this number goes down here. And again, what did I say we needed to make sure? Because if I just write it here, it looks like I have 32 oxygens. Is that true? No. So what do I need to put around this thing? Good. So we put brackets around it, and we say we have 2. Because again, what's this thing look like? It actually looks like a chlorine with 3 oxygens around it, like that. Does that make sense?
Mhm.
And we're saying that I have 3 of these.
How come when you
2 of them.
got
2 of them. Sorry, 2 of them.
the 1 down,
Mm-hmm.
it went positive, but the other one's didn't? That's what you need to change it to.
We don't take the sign. It's just the number, because this is
Oh,
just a
okay.
trick. Good question. Yeah, we're not flipping signs, nothing like that. It's just the number we're interested. Because what we're really saying is that it takes 1 magnesium to cancel the charge of 2 chlorates.
Sorry.
All right, and so what would the formula of this be when all is said and done?
Mg
Mg?
brackets
Yep,
ClO3
yep,
2.
good. So magnesium chlorate has a formula of MgClO3, right? And of course, we could obviously go the other way. I could say, what is the name of K3PO5? What's the name of that guy?
Potassium phosphate.
Potassium for sure. So potassium. And then you're not going to find PO5 on here, but if you look, you'll find PO. Maybe. But you see the phosphate is PO4. So then you have to know from this chart that when you add one more oxygen, because we'll talk about PO5, it goes up in the chart. And so what do we add to the beginning of the name? Per. So it won't be potassium phosphate, it'll be potassium perphosphate. That's right. So all you do is you have to know that we add per to the beginning of the name of that ion. Yeah,
Yes, Sarah, within.
absolutely put the numbers on the board.
Okay.
And so this will be potassium perphosphate. There we go. Does that make sense? Okay. We have a little bit of time left. And so today's edition is a brief one. All right? And it's on the topic of acids. All right, and there are two types of acids. I mean, there's more than two types of acids, but there's two types of acids that we're going to name in grade 11 chemistry. All right, the first one are what we call binary acids. What does binary mean? Hell, what's a bicycle? Yeah, two wheels. So this would be an acid that's made up of just two. We don't make Yay, very good. Yeah, we don't make
What would you say?
elements.
I said
Yeah.
protons.
Well, you're actually, ironically, you're not far off. But these are acids made of just two things, made of two elements. And maybe from grade 10 chemistry you remember, maybe you don't, but what does one of those elements have to be? What does an acid always release if we dissolve it in water? Do you remember? If you don't, it's okay, because I'm totally going to write it down in like 3 seconds. But maybe you do remember. No. When you dissolve an acid in water, it always releases, don't write this, it always releases these guys, little H plus ions. So to release H plus ions, the acid must be made of hydrogen. Good. So all of the binary acids are H and something else. That make sense? Yeah, sure. Why not? So it's hydrogen and a group 7 element. Actually, I guess we should call it group 17. These are the second to last row of the periodic table. Look at your periodic table. What are they going to be?
Chloride, bromide, iodide, acetate, acetate.
Good. So we're going to have HCl.
Is that 17?
Yeah. HFR, right? Oh, HF, sorry. What am I doing? Not francium. Fluorine. HBr and HI. These are the ones we're going to worry about. Those are the only 4 binary acids. There's only 4 of them. And they're super easy to name. You should know HCl. You've probably used it before. Hydrogen chloride, listen, is exactly what it's called when it's a gas, which is how it starts out. So you're not wrong. It would be hydrogen chloride, but when we dissolve it in water, we now give it its acidic name. So that's actually a good answer. It totally is hydrogen chloride is the thing. But then when we dissolve it in water, we call it, very good, we call it hydrochloric acid. Now, HF is totally hydrogen fluoride, but when I dissolve it in water, very good, it becomes hydrofluoric acid. All right, bromine. This would totally be, HBr is totally hydrogen bromide, but when we dissolve it in water, it's going to be called, yeah. That's an acid that likes to, like, I don't know, drink lots of beer and hang out with its like frat buddies and play Call of Duty. Hydrobromic acid. It's probably majoring in, let's say, sports management, rec and leisure. Yeah. not that there's anything wrong with that.
Yes, there is. Any major course of study that never starts before 11, and they still show up in pajama pants.
Never mind. As one of my electives, I took music appreciation to the rec and leisure department, and it was great. Best course ever.
Did you turn the lights on, or did you just listen to music?
We just appreciated music for a while. It was real good. Anyway, okay, HI would totally be hydrogen iodide, but again, when we dissolve it in water and it becomes an acid, we call it, this one's weird. See if you can get it.
Hydroiodide.
Close, try it again.
Hydroiodine.
Yeah, they take the IN out. So it's hydroiodic. You were all very close. So there we go.
Oh, excuse me.
Yeah.
Is this like a separate note? Or
Yeah, there's a new note
Okay.
on acids.
Okay.
Yes, yeah, that's fine. We'll just talk our way through it. So those are the nice easy ones, okay? These are the easy ones. But then there's a second type called oxy acids. Well, they're made of something that has a lot of oxygen. They're made of something that has a lot of oxygen. They're made of these guys. They're made of the radicals. So this is hydrogen plus a radical. But wait, there's so many radicals. Do they all have to have a different name when they're an acid? Yeah, they do. Yeah. Okay, so let's take a quick look. It's not as bad as it looks, because if you look at this chart, all of the radicals end in one of two things. What do they end in?
8 or 8.
8 or 8, right? You can have perchlorate or chlorate or chlorite or hypochlorite, right? But either way, it ends in 8 or it ends in 8. So we're just going to change that a little bit for acids. So an example of one would be H2CO3. Now, CO3 is what radical? What's it called? Carbonate. Good. If you go back and look at our radicals chart, you can see that CO3 is carbonate. Can everyone see that? So this is hydrogen plus carbonate dissolved in water. All acids are dissolved in water, right? You knew that? That's something you should remember from grade 10. Okay, and the name is carbon, not 8, but carbonic acid. All right? Maybe I'll even highlight that ick, because it gives us the first rule. All we do to name these is replace 8 with ic acid. And note what it is not. It is not hydrocarbonic acid. It is not hydrogen carbonic acid. Does hydrogen appear anywhere in that name?
No.
No. The acid tells us that it's with hydrogen, okay? So we do not call this hydrocarbonic acid. It's just carbonic acid. Likewise, CO4, H2CO4, this would now be not the carbonate ion, but the, nope, CO4 we're going up, so it would be percarbonate, right? So this would be percarbon, and all we do is we replace the 8 with ic acid. So rule 1 is that we always replace 8 with ic. The bell's going to ring, just give me 30 seconds, okay? Because it won't take us long to finish this. Yes, I'm going to send you a few textbook questions. If you check the OneNote, the pages you need to do will be online. Just a little bit of practice. The second rule is that we replace ite with us. So H2CO2, well, that's hydrogen. And then what do we call CO2? What's that? That's carbon ite, right? Oh, that should say us acid, obviously. So this is hydrogen and carbonite. And so what will it be called if we replace ite with us acid? That's very good. So this would be carbon us acid. And so if you know how to name the radicals, naming acids that involve the radicals is actually really easy. Does that make sense? Okay. Hey, I beat the bell. So at the bottom of this page on the OneNote, I will put the homework questions. I should have done that, worked them out beforehand, but I totally forgot to, if I'm being honest. This isn't me being like coy and saying, hey, I want to make sure you check the OneNote. I just forgot to assign homework, but I will do so. When you come on Monday, there'll be next week's assignment package. So make sure you get this one done over the weekend. It does not take long, and it's very straightforward. If you don't know how to do something, go through the notes. These are a really good way. In fact, believe it or not, do you know what the biggest comment I got last semester? At the end of the semester, I'll give you a survey that says, what did you like? What did you not like? What should change? And you know what? Almost every single person in the class said, and I've never heard this in a class before, they said, we wish there were more weekly assignment packages, because what it actually helped people with was knowing if they were keeping up with the material or if they were falling behind. So I've actually built a few more of them in, and it really does help you, because if you can do the assignment packages, then you know that you've kept up with the material. Does that make sense? All right, have a great day. Have a great weekend. Do check online for the homework. It should be up momentarily.
Can I ask you